Hey friends, in today's video we're going to do things a bit different compared to other training videos that I do. So what I did is I went to my YouTube channel, I went to comments, and I looked for 5 specific questions that are somewhat common to other viewers. And I printed the papers out. So as you can see, I have 5 papers, 5 questions. And the idea is that I'm going to go ahead and read the question or the statement, and the answer is going to be me showing you the answer on the actual unit. Now, most of these questions I have answered them personally, but of course it's better to be able to see it with your own eyes. And I am going to try something different today too. The tripod mount, I like it, but it's getting a bit old. I tried looking for other cameras that might work with the videos that I do. But I found something that I might start using moving forward is a neck mount. And I already bought other stuff, other gadgets to make it easy to kind of give you guys the point of view, but at the same time be able to zoom in, really zoom into the boards, to whatever I'm looking at, so you can see what's going on. And before I go ahead and read the questions and the statements here, I want to thank everyone for your support. It's been a little bit over a year now that I've had my YouTube channel, and the support has been tremendous. And so if you're watching my videos and you haven't subscribed, please subscribe. It really does help with me being able to dedicate more time to me doing the videos and helping you guys out in the field. So these are the questions, and I'll kind of summarize them. I have Texas engineer, and his question is kind of somewhat similar to other questions that I've gotten. It has to do with an ECM motor, right? And so this question was submitted under the HVAC inverters video, but he's basically talking about how the ECM motors work, variable speed. So the idea behind this one here, I'm going to show you how to check an ECM that has a 5-tab speed. Now I'm currently working on one that has a 16 speed tab. I just have to get my hands on a motor, but I pretty much understand them now. So the first one's going to be showing you how to check an ECM motor, high voltage and low voltage. So thank you, Texas engineer, for sending the question in. The second one's going to be by David Miller, TH4DB. And his question is, how does the unit know when it's going to stage from heating 1, right, W1, to W2, stage 2 heating? How do we do that on the thermostat? So I'm going to show you on the thermostat how to do that. So thank you for sending that question in. And then dear Carto, apologize if I'm mispronouncing your last name. What would cause a disconnect on a furnace to burn up? So I do have something that I'm going to do to the unit intentionally that might cause a disconnect to burn up. And I'm going to be using a thermal camera. And I'm actually going to, this thermal camera that I'm going to be using, I am going to create some videos separately to this video. I really like it, and they have asked me to sponsor them. I'm very careful what I say yes when it comes to sponsoring. I really don't like to do that, but so far this thermal camera has been pretty good, and why not? Why not do videos that have to do with HVAC and how a thermal camera, specifically this one, how it can come in handy to help you out in the field. The fourth one is what happens with an indoor motor when there is a filter. Will the amps go up or down? And you're going to see how I'm going to do, I'm going to show you a PSC motor and an ECM motor. Both are going to have restrictions. You're going to see those amps change. And the last one again, and the fourth one was by Rocker 8692. The fifth one is again by Deer Cardo. Good questions, by the way, that you're asking. What would cause the compressor to pull high amps? So I'm going to simulate 2 specific things that that would probably cause your compressor to amps go up, and we'll do it. We're going to do that. So we're going to go over the first one with an ECM, how to check an ECM. We'll go over second, third, fourth, and fifth questions. And my goal is to be able to do this once a month. I think it's a good idea. So let's go ahead and get started with the first question: how to check an ECM motor. So let's say you go on a service call and you're calling for cooling. In this specific package unit, this is a heat pump. So we're sending 24 volts to the contactor coil and the reversing valve. And sure enough, the compressor turns on, your condenser fan turns on, but you notice that your ECM, right, your indoor motor is not spinning. The squirrel cage is not moving. You don't sense any air that's actually moving. And so how would you check if an ECM motor is working or not? So we're gonna check voltage. So I am gonna use the tripod mount here, but in the other ones, I might use a neck mount, just a heads up. But with an ECM motor, you have a plug right here. So I'm gonna show you how to check it right here. If you were to check it over here, you would have to follow the wires and see where they go to. So your high voltage typically goes on this side where you have high voltage present all the time, and then your low voltage goes to the board. But we're gonna go ahead and I'm gonna go ahead and show you how to check it right here, okay? So a couple of things to kind of just make sense of here. So you got a bunch of wires, right? But if you look on the top, you got numbers 1, 2, 3, 4, 5. So on top, you got 5 wires, 5 speeds. So these top 5 only receive 24 volts. And number 1 is the slowest speed. Number 5 is the fastest speed. So in this specific package unit, the way it's wired, we have it so when we call for cooling or heating, we send 24 volts on this one here. But you can always change the speed if you want to. But so one test is going to be checking for low voltage. With an ECM, you also have high voltage present. So top is only low voltage and only one can get 24 volts at a time. On the bottom right here, let's go ahead and zoom in a bit more. On the bottom, you have your high voltage. So your yellow, you see that? Your yellow and your black, that's your 208 high voltage. The green one is your ground, and the brown one is your common. Just like this is 24 volts, the brown one is your common, okay? So let's go ahead and check that. I'm gonna go ahead and call for cooling. I do have it jumpered so that we don't have to wait for the thermostat. Okay, I just heard it turn on. So let's say you go to a job and you're calling for cooling and it's not spinning, right? How do you confirm if it's a bad motor or if the board is not sending the appropriate voltage? So how you would check it, you have to put your meter on voltage, right? So let's go ahead and get a little bit closer right here. Okay, so what we're gonna do, you can do it with these leads here. Typically, you do want to use a skinnier lead, but if you notice on this specific plug, I do have enough space to put it on the back without damaging the wires and the connections there. So let's go ahead and check first for high voltage, okay? So let's go ahead and do that. So what I'm gonna check, all I'm doing is I'm gonna check my black and my yellow because that's my high voltage. So go ahead and I'll move my hand right now so you can see the voltage here. But I'm gonna go ahead and put it on the yellow one, and on the black, just go ahead and push it all the way in. You see that? I'm getting 208, okay? 208. So have in mind with an ECM, even when you're not calling for cooling, that high voltage will always be there. Do not disconnect it with power being present there, right? With power here, do not disconnect it and connect it to check voltage and then connect it back. You will mess up the ECM motor. So in this one, you can just check to the back, and sure enough, we got 208. For my low voltage, I'm gonna go ahead and check common because we just said the brown is common, and we just said it's sending 24 volts on the black one. I'm gonna go ahead and check that, okay? And you see, I'm getting about 24 volts, okay? And that's it. That's all you're doing for an ECM. You're checking if you have high voltage and low voltage when you call for cooling. And if you got voltage and it's not spinning, that motor is not spinning, it's acting weird, it could be a bad module that went bad. Typically, it is the module on these that go bad. But all you're doing is just confirming, and you need to confirm if you have low voltage and high voltage present. Now, of course, confirm that all the wires from here go all the way back and that everything's wired correctly, that any wires are not cut or ripped. Make sure of that first. And when you call for cooling, you're gonna confirm high voltage and low voltage. If you don't have it, then you have to go back over here. What's going on? Why aren't we sending power over here? If we do have it and the motor is not spinning, then most likely the ECM, the module on the ECM went bad. All right, the second question is, how do we set up the thermostat so we can get stage 2? Because, and in this specific example, this one has second stage cooling, and this one has second stage heating. But if you don't set it up on the thermostat, you will always be on stage 1 cooling and stage 1 heating. You actually have to tell the thermostat that it has 2 stages and set it up when to call for second stage. So for this one, and I'm gonna do it on this thermostat because this thermostat has a stage 2 capability. We currently are working on getting a thermostat that has stage 2 right now. Right now, we're just running it on stage 1. But this will apply whether you're working on stage 2 furnace or stage 2 cooling. So let's go ahead and go to the thermostat. Okay, so this thermostat, one thing about this, you have to go to the installer options. So with this one specifically, and have in mind, there's going to be different ones that sometimes you have to push 2 buttons. You have to go ahead and hold this one, and they're all going to be different. So I already went through the manual. And so one thing first is make sure that you have the capability to do stage 2 and stage 1. So for this specific one, if you can see right here, you see, it's got the ability to do stage 2 cooling and stage 2 heating. So that's one. Your thermostat has to have the ability to do that. If it doesn't, then you can't do this. You have to get the right thermostat. Okay. The second thing is you got to go to the installer option. So on this specific one, just be, patient here. I'm just going to take a little second. I have to go to the actual installer options. But with this one thermostat here, this Honeywell, I have to go to the actual dealer information, get the code 1849. And then I go to installer option, select, and then type in 1849. With this one, this is how it is. 1849. Okay, boom. Now you're gonna go to installer setup, and this is where we're gonna spend our time here. And it seems like, let's see, select. Oop. So for some reason I got out of that page. Let's go back there. 1849. Okay, there we go. Installer setup. So let's go ahead and on installer setup, click select. And there's going to be a lot of different settings, okay? We're only looking for 2, okay? We're going to keep it simple. There's a lot, and the manual will tell you more. But we're going to go to where it says the heating part is going to be important. So on this specific package unit, this is a stage 2 cooling with stage 1 heating, but it's not a heat pump. It's using gas. So for heating, you would have to put conventional forced air. This is where you would change it if it was a heat pump or not. You see, heat pump now. But it's conventional forced air. So this is where we're going to get to, stage 2. Right there, you have to put that it has 2 stages. You actually have to do that. If you don't, then that's it. It won't work on with stage 2 cooling. So you have to first do stage 2 cooling. That's the first step. The next step, you're going to go to, at least with this specific thermostat, right here, control options. So we're going to select the advanced options, press select on this one. Actually, no, press. So you have the option to put basic or advanced. We're going to keep it at advanced. And then push next. And go ahead to right here. That's the point I'm trying to get to. Cool, differential, stage 2. So you see you're able to change the set point here. You got a comfort. You got a 1 degree, 1.5, 2, 2.5, 3, 3.5. That's the greatest. So it's simple. If you have a set point of 70 degrees, okay, you have a set point of 70, okay, and the ambient temperature in your house is 72, and let's say for example we choose 3.5, okay, 3.5 degrees, okay, so that means that from the ambient temperature in your house and the set point, it has to be greater than 3.5 to do stage 2. So if in your house you put a set point of 70 and your ambient temperature is 72, it's only going to do stage 1 because it's not greater than the 3.5 degrees. But let's say now in your house, your set point is 70, and you call for cooling and the inside temperature of your house is 75, you see that's 5 degrees away from your set point. 5 degrees is greater than 3.5. So that system's gonna go into stage 2. So that's gonna be important when checking a thermostat with stage 2 to look for the setting so that it can operate under stage 2. And there's another setting too that says comfort. The actual manual tells you a little bit more about that. It tells you that comfort sometimes it bypasses stage 1 to do stage 2 based on time. So the manual will tell you more information on that. But regardless of whatever thermostat you're working on, this is the idea. You're supposed to go to the settings behind it. Make sure you put it to 2 stages of cooling, and like in this case, or 2 stages in heating. If it's 2 stages of heating, then this would be the same example, right? You would go to right here, you see? Oop, no. Don't cancel. Next, 2 stages of heating, put yes, next. And then go to, you're gonna see it right here, right there. Heat differential stage. Same concept as cooling, and you could put comfort or 3.5. And it's the same concept, right? If your ambient is further away it is from the set point, if it exceeds that 3.5 and it's 5 degrees colder, it's gonna do stage 2. So you can set the set point or choose comfort. But it's important to read the manual to understand that first, that it can do stage 2, and setting it up so that it actually turns the system on stage 2 heating or stage 2 cooling. So what can cause a disconnect to burn up or maybe see burnt marks, right? Let's say you are dealing with a disconnect that supplies a furnace. So it can be a 120 volt disconnect, or a high voltage disconnect where you have like 208 volts, like this disconnect right here. And let's say that all your loads are okay. Your compressor, your condenser fan motor, your indoor motor, anything that's gonna pull a lot of current, nothing is shorted to ground. None of these lines are touching the metal. Everything checks out, but something's going on with your disconnect, right? You find that maybe your fuses are going bad, right? Like I said, fuses go bad. And a lot of burnt markings. Well, what could happen is these wires here are not tight enough. And I'm gonna show you with a thermal camera, how to check if it's overheating or not. And there's another little test that you can do with the meter, but a thermal camera will confirm it. But in this specific one, this is going to my load. You see how loose? I want you to see how loose that wire is. You see that? It's moving a lot, right? You do not want to do that for especially where the wire, you're gonna have a lot of current going through. Now I do have to tighten this just very little, just a little bit more. If not, it won't make contact, because I gotta actually turn on the compressor and show you what would happen if it's loose. And it's still loose, right? It's still loose. So think about a car. If a car is traveling and it's going through a speed bump, if it was driving 5 miles per hour, it would go over that speed bump, nice. It wouldn't be a pretty bad impact, because it's going over that speed bump just slowly, right? And then it's gonna continue. But what if that car was going 90 miles per hour and it hits that speed bump? There's more of an impact. Same thing with current. Imagine current like little balls, right? Little balls, and in that current, those little balls are going through a speed bump at a fast speed. Then there's going to be more of an impact. So when those wires are not tied, it ends up becoming a resistor instead of a conductor. So they have to be tied. Everything where you're going to have a lot of current going through, there's going to be a lot of heat. It has to be tight. And in this case, this is a bad example on this one. On this one here too, what I did over here, the fuse is loose as well. You see, this is loose on this side. So I intentionally created these issues. Another one too, here, this wire here, this is also loose. You see this wire here? Let's see if I can get you a little bit closer. You see? Loose, okay? So this can be part of your maintenance whenever you go to a job too, just making sure that it's all tight. So I'm gonna show you two quick things that you can do. I'm gonna go ahead and turn it on here. Okay, turned on. Now this might not work, and this is where having a thermal camera would work out, but I have seen this work on a breaker to see if there's a voltage drop, and if there is, there's something going on in that breaker. But typically you can check your line and your load, and if you see anything greater than 2 volts, then it's bad. There's something going on. In this case, it's just the line. There's not enough resistance. It's okay, but that doesn't mean there's no issue though. The right way of doing it, and this is where you would have to invest, is getting a thermal camera. So look at this right here. I already have one right here. I want you to look at this wire right here. This is the one that's loose. Now, I don't think we'll be able to see the fuse as much, even though it's loose, because it's covered by this part here. But I want you to look at this, okay? Just give me 1 second as I get it a little bit closer, okay? Do you remember that wire right here? This wire, and it happened to turn off on me. So let's go ahead and turn it back on here, okay? So right now, you're probably able to see that it was a little bit more orange than the other wires, okay? So let's go ahead and get an idea. So you see, so you got one wire there, another one right here. This is the one that was loose, and then this one here was the one that was okay. The one that's loose, look at the color. It's a lot brighter than the other ones because it's not tight enough. There's more resistance. That those electrons are making more impact because there's more resistance. It's not so much a conductor because it's loose. It's generating more heat, and that's what could cause your actual fuses to go bad. Your actual fuses can go bad because of that heat it's generating, because it's not tight, which is such an easy thing to do, right? Look at this over here now. Look at this contactor. Okay. Let me get it here situated. Okay, let's see. So we're checking for, there we go. You see the wire on the bottom right. You see this right here? Right, this is where my finger's at. That's the wire that's loose. So you see that? You see how it's a little bit more orange than the wire on top? Because it's loose. It's becoming there's resistance. Current is making more of an impact. And so it's such a simple thing that you can do to avoid, right? It's just by simply checking that it's tight enough, okay? So the way you would fix it, let's go ahead and turn this off. The way you would fix it is simple. Now, what I did right here, this is the one that has power, so I'm not gonna mess with that. I'm just gonna mess with the one that is the load. All you gotta do, and it's such a simple thing, you can do this as part of your maintenance, just tighten it. You see, how many turns do I get? 1, 2, 3. Pretty tight, and then make it pretty tight. Don't break it, but just tight enough. And then I always do the little tuck test, right? Pull test rather, you see, not going anywhere. And then on this one here too, right? Any parts, even with low voltage, you're gonna check that everything has a good connection, you see? Okay, and then tight, okay, and that's it. That's all you gotta do. And like I said, this is part of maintenance. When you go to jobs, just make sure that everything's tight. Like that, you can prevent the wires from overheating and possibly other issues. I did forget to mention this in the previous clip. As part of your maintenance, if you go to your disconnect and the forks are really loose, that's gonna be an issue. So for example, you see right here, I'm gonna put this fuse. There's a lot of play compared to this one, right? So everything can be okay with the actual unit itself, no shorts, but your fuse can go bad over and over because there's a lot of resistance, right? There's a lot of current going through, and it has to be tied like a nice path. But if it's loose, more resistance, more heat, and it can cause your fuse to go bad over and over. So all you have to do is just kind of bend the forks inward, right, a bit, and then make sure that everything's pretty tight right here. Tighten that up, you see, not going anywhere. So this one might need a little bit more love here. So a little bit more, okay, there we go, not going anywhere. So I'm gonna go ahead and send power to the unit. Okay, so what's going on with this question now, right? So the question number 4 had to do with airflow. So what's going to happen on a system where you have an air restriction? Are your amps going to go up or down? Is it going to be working more or working less? So remember, this one here has an ECM, right? An ECM motor. And that one there has a PSC. We're going to test both. So which one's going to pull more or pull less with the restriction? Whether on the supply side, right? Closed supply vents or dirty filter, right? Which is going to pull more? Which is going to pull less? Well, let's find out. Let's go ahead and do the PSC first. So right now I have it on the fast speed. I have it, it's cooling right now. So I'm going to go ahead and check my amp draw right now currently. I'm going to go ahead and put it on amps. And I'm going to go ahead and check the neutral here. Give me 1 second here. Okay. So right now, we are reading 4.5 amps, okay? 4.5 amps. That's how much we're pulling right now, okay? So what's going to happen when I close the return? Is that amp draw there, right? 4.5, is it going to go up or is it going to go down? So it was at 4.5. Let's go ahead and create a restriction. Okay, what happened to it? It went down. Okay, you see now we're at 3.8, about 0.7 less. So this motor here, permanent split capacitor motor, this is the one with the capacitor, right? With this specific motor, it doesn't know that there's a restriction. It's just gonna work with what we're supplying it with. So now that we created a restriction, there's less airflow, less to work with, less current. So with the PSC motor, whether you have a restriction on the return or supply, your current will go down, okay? And that, you might think, well, that's okay, but not really, because these motors are intended to work at, at a certain temperature. All that heat now is collecting in your motor, and overall, it's not good for the life expectancy of the motor, right? So I'm going to go ahead and let it breathe, right? And it went back to 4.5. Okay, so on the PSC, restriction, amps went down. With an ECM motor, are amps going to go down or up? So I'm going to go ahead and get the yellow wire. So have in mind, this one, I already determined which wire goes to the high voltage from there all the way over here. So actually, I do have to close this one off to get a proper amp reading. So I'm going to go ahead and put it on amps, clamp it around the wire. And right now we are reading 2.4, and that's on the high speed, 2.4 amps. Okay, so I want you to remember that number, 2.4, because now we're going to create a restriction. Okay, and I'm going to create it on the supply side. So just give me 1 second. Okay. Okay, you see that? I created a restriction. Only a little bit of air is coming through, but I created a pretty bad restriction. So now, let's check our amp draw. Our amp draw went up. What was the number? Was it, 2.4? We went up to 3.6. So with an ECM motor, because right now we have 24 volts going on number 5, the highest speed, it's trying to maintain a constant torque, right, for that speed. So regardless, if there's a restriction, it's going to ramp up more to make up for that restriction. But guess what? If you're pulling more current now, that's how these modules go bad. Now, don't get me wrong, they also go bad because of power surges. But this is why it's so important to change out the filters. With systems with an ECM, change out the filters, check the supply vents are open. This is a big one, making sure the return ducts are properly sized for the unit. The moment that you create a restriction, you can see right here the current went up, current is heat, and a lot of the ECM motors, when you look at the module, instead of it being green, it's kind of yellowish because it's pulling more current. Now, the only way it would pull less if you have a complete blockage, a collapsed duct. I've seen those when it's complete blockage, then the amp draw goes down. But think about it, in most cases, that doesn't really happen. In most cases, it's undersized return ducts, no maintenance, dirty filters. So it's gonna make up for it because there's a restriction, not a complete one, but there is a restriction. And that's gonna be the most common one. With a slide or somewhat of a restriction, it's gonna pull more current, more amps to make up for it. So on a PSC, the amps go down with the restriction. With an ECM, if it's not a complete blockage, right? If it's just a restriction, right? Just like a dirty filter or some closed supply vent or undersized return duct, with the restriction on an ECM, it's gonna have your current go up. Okay, and the fifth question we're gonna answer is, how do the compressor's amps go up? Right? So you are going to have amps, right? Obviously, because it's on and needs a lot of current to work, right? And right now we're pulling, if you see, 6.7, okay? Almost 6.8, okay? But we're going to go over two specific ways that your amps would go up, okay? And it's just good to just be mindful of it and keep an eye on it. So we said 6.8. So amps would go up if you have a dirty condenser. So I'm gonna go ahead and grab this mat, okay, put it up here, okay, and look at my amps go up. So that would cause the amps to go up, okay? Just be mindful of that. We have to keep the condenser clean. If not, your compression ratio is a lot higher. Your compressor is working hard for no reason. Your amps go up, okay? So that's one. And of course, you know, superheat and subcool is important too. Right now, I'm just showing you two different ways where your amps would go up, okay? So we'll let it go down to, what is it, 6.8, 6.7, 6.8. We're gonna prepare now the other way that amps go up. And the other way is if the system is overcharged, okay? So I connected everything right. I got my recovery tank, my gauge. My gauges here. I have my low side connected to my suction, my high side connected to the liquid line. And so, of course, I already connected it to the red because we need liquid for a blended refrigerant. I already purged, but just so you can believe me, just a little bit, okay? A little pro tip here, because we're not pulling a vacuum, right? This blue line does have a little bit of air, and you're gonna be charging on the blue side, because it has to go on the low side, so because the higher pressure goes to lower pressure. So we got to charge when it's on the low side. So what I like to do when I connect it, I like to just perch very little, right? Get some air out of that hose. Now I have just refrigerant going in there. So now that we have everything set up, and it might take me a bit, but 6.8. So let's go ahead and actually what I'm gonna do, I'm gonna be opening this, and you know we're charging because that number there is gonna go up. You see, look, you gotta throttle it. So you see the number is going up, 155, 160, right? And you gotta just throttle it. Be patient here. But we were at 6.8. Okay. 6.85 around there. But you see, it was around 6.9 because it was trying to, you know, work with that refrigerant. But I'm gonna go ahead and with this hand here, I'm gonna go ahead and charge it. Keep an eye on that. Okay, it's charging right now. 1, 2, 3, 4, a couple seconds. You see right there, it went up. Obviously, it climbs down because then it's, you know, going back to pumping. But you see, as I'm charging, okay, as I'm charging refrigerant, and if it's overcharged, then it has more refrigerant to pump. It has more work to do. Your current goes up. Now, this is just a little simple thing to show you, right? But a lot of the times, you go to a job, and especially with the TXV, and you find that your suction pressure is a little bit higher than usual. Your superheat is okay because it has a TXV. Your high side pressure is a little bit high, and your subcool is high. Let's say your subcool, and have in mind, I have nothing connected. This is just your imagination, but let's say your subcool is 20 when it should be around 8 to 12. you're over 12 degrees on subcool. That compressor, you're going to be pulling a lot more amps, more energy for no reason. So you would have to recover, and you'll see your amps go down. So you want to keep the system, the rated load amps, you want that compressor to work under that rated load amps, but it's so easy for it to go above those rated load amps by having a dirty condenser, and also by having the system overcharged. But so right now I'm not talking so much about the diagnostics, checking superheated subcool. It's just to show you, right? It's just to show you that as the compressor has more refrigerant, I'm gonna charge right now, 1, 2, 3, 4, 5, couple seconds. If it has more refrigerant, it's pumping more. As it's pumping more, it's doing more work, more current. I hope that you were able to enjoy today's video. I love getting the questions on my YouTube channel. And sometimes I try my best to answer all the questions, but now that I have a TikTok and Instagram where I post shorter videos and I get questions there too, it's hard to go through all the questions. But I don't mind doing this. I don't mind doing a similar video like today, maybe twice or every month, where I get or select 5 common questions that I get on my channels and make a video on it. Like today, a long video, and then do shorter videos on each question. Now, I have gotten questions about other things: refrigeration, chillers, VFDs, boilers. Although I do understand those things to a certain extent. 1, I don't have a lot of experience with those, and 2, I don't have equipment. I don't have access to them. My niche, or what I would consider myself to be more of an expertise, would be on the HVAC, residential, light commercial, and building automation. But that doesn't mean that I'm not open and making videos for refrigeration, chillers, and other things. I love to learn, and you probably have gone through that too yourself. Something happens. You learn how to learn. So once you get this down, you can always learn more things. So I do have an email on my YouTube channel. If for some reason you're getting rid of a VFD, a boiler, a chiller might be a little bit too big, but maybe a refrigeration system, I can always pick it up, learn about it, and make a video. So just putting it out there. But I will continue making videos on HVAC, residential, light commercial, and possibly in the future building automation. And keep asking questions. I'll read through them when I can, and I'll do my best to answer all the questions that I receive from you guys. And once again, I want to thank every single one of you for your support. This year is going to be a fun year. I will be at the AHR Expo in Vegas next month. So if you're there, I will see you there, and we can talk and catch up. I hope that today's video helped you out, and I will catch you on the next one.